The weapon most feared by the Japanese in the Pacific was not what they expected. While the Imperial Japanese Navy focused its resources and strategies on defending against heavy bombers and large-caliber naval guns, a silent and radical transformation was occurring in American hangars and laboratories. The Mark 13 aerial torpedo, initially labeled by Americans themselves as the worst torpedo ever made, was secretly undergoing revolutionary modifications that would alter the course of naval warfare. Japanese strategists, imbued with unwavering confidence in their naval technological superiority, failed to realize that their enemies were converting a resounding failure into a decisive tactical advantage. This underestimation, rooted in a perception of invincibility and rigid adherence to established doctrines, would prove to be a catastrophic miscalculation for the empire of the rising sun. The narrative that would unfold in the following years would not only be a story of engineering and combat, but also a profound study of strategic blindness and the human capacity for adaptation under extreme pressure. The central thesis of this documentary is that the Japanese failure to recognize America's rapid and systematic innovation capability, especially in the Mark 13's development, created a fatal blind spot that undermined their naval supremacy and decisively contributed to their defeat in the Pacific. Between 1942 and 1944, the Mark 13 evolved from a national disgrace into the weapon that would sink some of the most powerful ships in the Japanese fleet. This metamorphosis was not a stroke of luck, but the result of tireless and methodical effort. It all began with desperate engineers working in makeshift laboratories, determined to solve seemingly insoluble problems. Every recorded failure, every torpedo that disintegrated upon hitting the water or veered off course, provided valuable data for a continuous process of improvement. This empirical approach, based on meticulous observation and incessant experimentation, contrasted sharply with the Japanese mindset. Meanwhile, Japanese intelligence remained fixated on conventional threats, such as the growing bombing capability and the evolution of American fighters, ignoring the increasingly evident signs that a fundamental change was underway in American offensive capabilities. They saw what they expected to see, not what was truly happening. The ingrained belief in their own technological superiority, forged by years of meticulous development, prevented them from conceiving that an adversary could overcome such profound failures in such a short time. Commander Mitsuo Fuchida, a legendary Pearl Harbor veteran, observed intelligence reports with growing frustration. The documents described repeated failures of American aerial torpedoes during attacks against Japanese convoys. Captured American pilots, under interrogation, confirmed that the Mark 13 was considered useless by their own crews. For Fuchida, this information served only as a comforting confirmation of Japanese technical superiority. He had witnessed firsthand the devastating power of the Japanese Type 93 torpedo. The Long Lance, a marvel of naval engineering that boasted an impressive range of 24 nautical miles and a speed of 49 knots. In contrast, reports indicated that the Mark 13 often failed to travel even 1,000 yards before sinking or drastically veering off course. This technological disparity reinforced Japanese confidence that they would maintain naval supremacy indefinitely. Fuchida, with his vast experience and deep knowledge of naval doctrine, could not imagine how the Americans could overcome decades of Japanese development in naval armaments. The idea that an industrially inferior nation could quickly match this expertise seemed absurd to the Japanese military mindset of the time, which valued tradition and gradual perfection. The empire's engineers had perfected their torpedoes through rigorous testing and constant innovations, a process that had consumed years of dedication and resources. With each new iteration, the Type 93 became more lethal, more reliable, a symbol of Japanese ingenuity. This success story, however, created a kind of strategic myopia. The belief that technological excellence was a product of slow and methodical, almost organic evolution, prevented them from understanding the radically different approach Americans were adopting. To the Japanese mindset, the idea that a problem as complex as the Mark 13 could be quickly solved through an experimental, trial-and-error approach was almost unthinkable. They viewed American persistence as stubbornness, not resilience, With each Mark 13 failure, Japanese confidence solidified, creating a psychological barrier that prevented them from seeing the emerging threat. This conviction, though understandable given the circumstances and history of success, would become one of the Imperial Navy's greatest Achilles' heels, a blind spot that would prove costly in lives and ships. At the Naval Torpedo Station in Newport, Rhode Island, a technical revolution was quietly beginning. Lieutenant Commander Charles "Chuck" Mommsen, Jr. led a team of engineers determined to decipher the Mark 13's chronic problems. Unlike the Japanese, who clung to established designs and an incremental improvement process, the Americans adopted a radical experimental approach. Each defective torpedo was meticulously examined, photographed, and dissected. Mommsen discovered that the main problem lay in the water entry mechanism. The Mark 13 weighed 2,216 pounds and measured 13 feet 6 inches in length, but its hydrodynamic shape was inadequate for high-speed launches. When launched from aircraft flying above 200 knots, the torpedo frequently broke apart upon hitting the surface or plunged at erratic angles, rendering it ineffective. Mommsen's team began testing different stabilizer and entry mechanism configurations. Using makeshift test tanks and high-speed cameras, they documented every aspect of the torpedo's behavior during the critical seconds after launch. This scientific methodology, based on data analysis and controlled experimentation, contrasted sharply with the Japanese approach, which relied primarily on tradition and accumulated experience. Admiral Chuichi Nagumo, the same carrier task force commander who attacked Pearl Harbor, received weekly briefings on enemy capabilities. However, information regarding the Mark 13 remained consistently negative. Japanese field reports documented spectacular failures, torpedoes exploding prematurely, others running in circles, and some simply sinking without activating. Nagumo interpreted this data as evidence of American incompetence in naval engineering. The Imperial Navy had invested decades developing the Type 93, testing it under extreme conditions, and refining each component. The idea that Americans could quickly overcome this technological advantage seemed impossible to him. Nagumo ordered naval intelligence to focus on more probable threats: new American fighters, improved radars, and aerial combat tactics. The Mark 13 was classified as an insignificant threat in Japanese strategic reports. This decision freed up intelligence resources for other areas, but created a fatal blind spot. While the Japanese monitored developments in aviation and electronics, they ignored the growing signs that a fundamental transformation was occurring within American arsenals, a transformation that would redefine naval warfare. Nagumo's confidence in Japanese superiority was not unfounded. It was the product of a military culture that valued perfection and tradition. He had led the force that inflicted a devastating blow to the American fleet at Pearl Harbor, an achievement that cemented his belief in his Navy's doctrine and technology. The idea that an enemy, whom he perceived as technologically inferior and less disciplined, could innovate so quickly to overcome its own failures, was an affront to his understanding of warfare. For Nagumo, American persistence with the Mark 13 was a sign of desperation, not determination. He viewed the failure reports as a validation of his own worldview, a confirmation that the Japanese path was the correct one. This mindset, though understandable in a context of previous success, made him impervious to any evidence that challenged his premises. The tragedy of this strategic blindness lay in the fact that, by disregarding a seemingly minor threat, Nagumo and the Japanese High Command were unknowingly opening the door to a vulnerability that would be exploited with devastating consequences. Dr. Robert Whitehead, grandson of the inventor of the modern torpedo, arrived in Newport in March of 1943 with special authorization from the War Department. His mission was to apply aeronautical engineering principles to the Mark 13 problem. Whitehead brought a unique perspective, expertise in fluid dynamics and projectile design, a field that traditional naval engineers might not have explored with the same depth. Working with Mommsen's team, he identified that the fundamental problem was not the torpedo itself, but the launch conditions. The Mark 13 had been designed for low-altitude, low-speed launches, But the realities of combat demanded much greater tactical flexibility. Pilots needed to launch from higher altitudes and faster speeds to avoid enemy anti-aircraft fire. Whitehead proposed revolutionary modifications, removable drag rings that would stabilize the torpedo during its fall, and a detachable wooden tail that would reduce shock upon water impact. These devices would allow launches from altitudes of up to 2,400 feet and speeds of 410 knots. Initial tests were promising, but Whitehead knew that each modification needed to be exhaustively tested. The team worked 16 hours a day, 7 days a week, aware that each day of delay cost American lives in the Pacific. Captain Tameichi Hara, commander of the destroyer Shigure, reported increasingly frequent encounters with American aircraft carrying torpedoes. His reports to the high command described ineffective attacks, with torpedoes often missing targets or failing to explode. Hara, a Guadalcanal veteran, had witnessed dozens of these frustrated attacks. On one occasion, he counted 7 Mark 13 torpedoes launched against his destroyer, of which only one functioned correctly, and even then, it missed the target by 50 yards. These reports reinforced the Japanese perception of technological superiority. Hara observed that American pilots seemed reluctant to use torpedoes, preferring conventional bombs even against naval targets. This preference was interpreted by Japanese analysts as confirmation of the Mark 13's inadequacy. What Hara did not know was that his observations were being recorded during a critical transition period. While he reported failures, American engineers were implementing Whitehead's modifications into production torpedoes. Hara's next encounters with American aircraft would be dramatically different, a change he could not foresee but would experience firsthand. In the modification workshops at Pearl Harbor, technicians worked feverishly installing the new stabilization devices. Master Sergeant James Jimmy Doolittle III supervised the conversion of hundreds of existing Mark 13 torpedoes. Each torpedo received a bronze drag ring and a specially designed balsa wood tail. The process was meticulous. Each component was weighed, measured, and individually tested. Doolittle maintained detailed records of each modification, creating a database that allowed for performance tracking. The first modified torpedoes were assigned to elite squadrons, experienced pilots who could provide detailed feedback on combat performance. Lieutenant Commander John Jack Waldron, leader of Torpedo Squadron 8, was one of the first to receive the improved torpedoes. Waldron had lost his entire squadron at Midway, partly due to the limitations of the original Mark 13. Now, he would have the opportunity to test the improvements in real combat conditions. The irony was not lost. The same torpedo that had contributed to his previous defeat could become his weapon of revenge, an instrument of retribution and a testament to American ingenuity. Admiral Isoroku Yamamoto, the architect of Pearl Harbor and a brilliant strategic mind, reviewed reports of naval losses with growing concern. However, his attention remained focused on conventional aerial threats. B-25 bombers and Corsair fighters dominated his strategic analyses. Yamamoto perfectly understood the power of coordinated air attacks, but his experience was based on high-altitude bombing and dive attacks. The concept of effective aerial torpedoes remained secondary in his planning. Intelligence reports continued to classify the Mark 13 as a weapon of limited effectiveness. Yamamoto authorized an increase in the production of anti-aircraft guns and interceptor fighters, but did not order specific improvements in torpedo protection. This decision reflected Japanese confidence that their superiority in naval armaments would remain unchanged. Yamamoto could not foresee that, within a few months, improved American torpedoes would begin to seriously threaten his naval formations. Japanese intelligence had failed to detect the fundamental transformation occurring in American arsenals. This failure of recognition would prove costly for Japanese strategic planning, an error that would echo in the depths of the Pacific. Yamamoto's vision, though insightful in many respects, was trapped in past paradigms. He had conceived and executed an audacious attack that changed the face of war, but his strategic mind, accustomed to the grandeur of battleships and the precision of bombing attacks, could not adjust to the idea that a previously scorned weapon could become so lethal. Japanese military culture, with its emphasis on honor and perfection, struggled to accept that an enemy could learn and adapt so quickly from its own mistakes. For Yamamoto, American persistence with the Mark 13 was a sign of a pragmatic mindset that he perhaps did not fully comprehend but dangerously underestimated. He viewed war as a chess game of calculated moves and brute force, while the Americans were playing a poker game where the ability to bluff and adapt was equally crucial. The irony was that the same genius who had planned the attack on Pearl Harbor was now blind to the threat emerging from the ashes of that very attack. Commander Eugene "Gene" Lindsay prepared his squadron for its first mission using modified Mark 13 torpedoes. The briefing was different from any he had conducted before. For the first time in months, Lindsay could instruct his pilots on aggressive torpedo tactics, including high-altitude and high-speed launches. The new modifications allowed attacks from 2,000 feet of altitude, offering significant protection against Japanese anti-aircraft fire. Lindsay explained the function of the drag rings, devices that automatically detached after 3 seconds of fall, allowing the torpedo to assume a stable trajectory. The wooden tail separated upon water contact, reducing the shock that previously caused mechanical failures. Lieutenant William Bill Esders, a veteran of 6 frustrated missions with original Mark 13s, expressed cautious skepticism. Esders had witnessed torpedoes exploding prematurely or running in random directions. Lindsay understood the hesitation, but emphasized that extensive tests had validated the modifications. This mission would be the ultimate test, real combat against defended Japanese targets, a trial by fire for American ingenuity. The tension in the briefing was palpable. The pilots, many of them scarred from previous missions where the Mark 13 had disappointed them, listened with a mixture of hope and distrust. They had seen their comrades fall, not just from enemy fire, but from the failure of their own weapons. The promise of a new torpedo was almost too good to be true. Lindsay, with a firm voice, described the technical details, the engineer's hours of work, the science behind the modifications. He knew that confidence would come not just from words, but from proof in combat. With each explanation, he observed the faces of his men, looking for signs of acceptance. The idea of launching a torpedo from 2,000 feet, an altitude that previously meant almost certain failure, was revolutionary. It was a leap of faith in engineering and adaptability. That briefing was not just about tactics. It was about restoring faith in a weapon that had been a source of shame and frustration. The mission that would follow would not just be an attack, but a validation, a demonstration that the tide of innovation was turning. The Japanese destroyer Akizuki was sailing in defensive formation when the first modified torpedoes were launched against the fleet. Captain Shigetaka Sato observed through binoculars as American aircraft approached at an unusually high altitude. Sato expected the familiar pattern: low, slow launches that would allow effective evasive maneuvers. Instead, American Avengers maintained an altitude of 1,800 feet and a speed of 350 knots during the launch. Sato ordered standard evasive maneuvers but quickly realized that something had fundamentally changed. The torpedoes descended in stable trajectories, without the erratic oscillations characteristic of previous Mark 13s. When they hit the water, they maintained a direct course toward the Akizuki. Sato ordered maximum speed and an emergency turn, but the first torpedo struck the destroyer amidships. The explosion of the 600-pound warhead opened a 20-foot breach in the hull. As his crew struggled to control the damage, Sato understood that he had witnessed a fundamental shift in American offensive capability. The report he would send would change Japanese perceptions of the aerial torpedo threat, but perhaps it was already too late. The scene on the Akizuki's deck was one of controlled chaos, but Sato's mind was in turmoil. He had trained for all eventualities, but this was one he had not foreseen. The precision and speed of the new torpedoes were terrifying. Smoke and steam rose from the breach in the hull, and the cries of the wounded echoed through the ship. Sato felt a chill down his spine, a sense that the rules of the game had changed without warning. The confidence he and his men had in their ship's invulnerability against aerial torpedoes was disintegrating with each explosion. He wondered how his superiors would react to this news. Would it be believed, or would it be seen as an exaggeration, an excuse for failure? The truth was that the Imperial Navy had become complacent, over-relying on its own technology and underestimating its enemy's capacity to innovate. The Akizuki, a proud ship, was now bleeding, a silent testament to a strategic failure that manifested in twisted metal and lost lives. In the Imperial Navy's analysis laboratories, technicians examined fragments of the torpedo that had struck the Akizuki. Lieutenant Commander Hiroshi Suzuki led the investigation, seeking to understand the American modifications. The fragments revealed unknown components, remnants of a metal ring and pieces of balsa wood with impact marks. Suzuki immediately recognized that these were not components of the original Mark 13. Metallurgical analysis of the ring revealed a specially treated bronze alloy, designed to withstand extreme aerodynamic forces before detaching. The wood fragments showed signs of precise engineering, calculated density, and a specific aerodynamic shape. Suzuki understood that the Americans had developed a sophisticated stabilization system, allowing launches under previously impossible conditions. His report to the High Command warned of significant modifications to enemy aerial torpedo capability. However, the Japanese response was limited, orders to increase vigilance, but no fundamental change in defensive tactics. The Japanese mindset had not yet fully assimilated the magnitude of the American transformation, a failure that would continue to haunt them. Suzuki's discovery was a shock to the analysis team. They had studied the Mark 13 for years, cataloging its failures and ridiculing its ineffectiveness. Now, before them, was evidence of an ingenuity they had not foreseen. The bronze ring, the balsa wood. These were elegant solutions to complex problems, testaments to a pragmatic and innovative approach. Suzuki felt a pang of apprehension. He knew this was not a minor improvement, but a fundamental re-engineering that changed everything. His detailed and urgent report was sent with the hope that it would be taken seriously. However, bureaucratic inertia and a deep belief in their own superiority were powerful forces. The idea that the enemy could have overcome such a great weakness in such a short time was difficult for many in the High Command to swallow. They had invested so much in the narrative of their own invincibility that the truth, when it finally presented itself, was difficult to accept. Admiral William Bull Halsey, known for his tactical aggressiveness, received enthusiastic reports about the modified torpedo's performance. In just 2 weeks, American squadrons had sunk 3 Japanese destroyers and seriously damaged 1 heavy cruiser. Halsey immediately ordered an expansion of the modification program. All torpedo units in the Pacific would receive maximum priority for conversion. Halsey understood that the window of opportunity was limited. The Japanese would eventually develop effective countermeasures. The strategy was to maximize the element of surprise while the enemy still underestimated the new American capability. Colonel Curtis LeMay, commanding land-based air operations, coordinated with Halsey to synchronize torpedo attacks with conventional bombings. This coordination would create tactical dilemmas for Japanese commanders, defending against high-altitude attacks while simultaneously facing torpedoes from multiple directions. Halsey authorized the accelerated production of drag rings and stabilizing tails, establishing 3 additional modification centers in the Pacific. The transformation of the Mark 13 was becoming an American strategic advantage, an asset that would shift the balance of power. Halsey's vision was clear. War was a race of innovation, and the Americans were now in the lead. He knew that surprise was a weapon as powerful as the torpedo itself. With each Japanese ship sunk, American confidence grew and Japanese morale declined. The coordination between air and naval forces, once a challenge, was becoming a lethal symphony. Japanese commanders, accustomed to facing predictable threats, now found themselves at a crossroads. If they concentrated anti-aircraft fire on high-altitude bombers, the torpedoes would get through. If they focused on the torpedoes, the bombers would wreak havoc. It was a dilemma they had not anticipated, a direct consequence of American adaptability. Halsey, with his direct and relentless style, was determined to exploit this advantage to the fullest, transforming the worst torpedo into a nightmare for the Imperial Japanese Navy. The war in the Pacific was about to enter a new and more brutal phase. Captain Toshio Abe commanded the heavy cruiser Chokai when it faced the first coordinated attack using improved torpedoes. The Japanese formation was sailing in waters considered safe, protected by air cover and destroyer escorts. Abe observed the approach of a mixed formation, dauntless dive bombers at high altitude and Avengers carrying torpedoes. The tactic was familiar, but something seemed different in the execution. The Avengers did not descend to the traditional low altitude. They maintained 2,200 feet throughout the approach. Abe ordered concentrated anti-aircraft fire on the dive bombers, assuming they represented the primary threat. The Avengers launched their torpedoes simultaneously, creating an attack pattern Abe had never encountered. 8 torpedoes descended in parallel trajectories, covering an area of 800 yards. Abe attempted evasive maneuvers, but the speed and precision of the modified torpedoes limited his options. 2 torpedoes struck the Chokai in sequence, causing catastrophic damage. As the cruiser sank, Abe transmitted an urgent alert. Enemy torpedo capability significantly increased. Review all defensive tactics. Abe's message echoed through Japanese communication channels, a cry of alarm that challenged the official narrative of superiority. Aboard the Chokai, the reality was brutal. Water flooded the compartments, and the ship began to list. Abe, a man of iron, felt the weight of defeat. He had relied on his ship's armor, on his crew's skill, but nothing seemed sufficient against this new threat. The coordination of the attacks, the precision of the torpedoes. It was something the Imperial Navy was not prepared to face. The scene of the Chokai sinking, a steel giant swallowed by the Pacific, was a grim symbol of changing fortunes. For the Japanese sailors who witnessed it, the invincibility of their ships, a belief so deeply rooted, was disintegrating before their eyes. The war was no longer about who had the biggest gun, but about who could innovate faster, who could adapt to the speed of change. Dr. Hideki Yukawa, a theoretical physicist from Kyoto Imperial University, was summoned to analyze the new American threat. Yukawa, a future Nobel Prize winner, applied fluid mechanics principles to combat reports. His analysis revealed that the Americans had solved the fundamental problem of hydrodynamic stability during the air-water transition. Yukawa calculated that the modifications allowed launches at 85% greater speeds than previously possible, dramatically expanding the tactical envelope. His calculations indicated that the stabilization devices reduced torpedo dispersion by 60%, significantly increasing the probability of a hit. Yukawa recommended the urgent development of countermeasures, including early detection systems and improved evasive maneuvers. However, his analysis came too late to influence Japanese strategic planning. The Imperial Navy was committed to ongoing operations based on outdated assessments of American capability. Yukawa predicted that without rapid adaptations, Japanese naval losses would increase exponentially. His prediction would prove tragically accurate in the following months. Yukawa's brilliant mind unraveled the science behind American success, but Japan's bureaucracy and strategic inertia were insurmountable barriers. He saw the numbers, the equations, the irrefutable logic of American innovation, and knew that the Imperial Navy was in grave danger. Yukawa's frustration was palpable. He had the solution, the understanding of the problem, but not the power to implement it. Japanese culture, which valued tradition and hierarchy, struggled to accept that an academic could have a clearer view of the battlefield than the admirals themselves. The tragedy of the situation was that the truth was there, clear as day for those willing to see it, but the power structure and ingrained mindset prevented action. Yukawa's prediction was not a guess, but a scientific conclusion, and the cost of ignoring it would be measured in sunken ships and lost lives. Lieutenant Commander Paul "Pete" Bowie led the first night attack using modified Mark 13 torpedoes. The mission targeted a Japanese formation anchored in Rabaul, protected by extensive coastal defenses. Bowie had participated in the original tests of the modifications and perfectly understood their capabilities. Darkness offered protection against Japanese fighters, but complicated navigation and target identification. BI used an innovative tactic, coordinated launch from multiple directions, creating a torpedo pattern that would be impossible to completely avoid. 12 Avengers approached from 3 different directions, each group launching 4 torpedoes in precise temporal sequence. The Japanese detected the approach, but the multiplicity of simultaneous threats overwhelmed their defenses. Coastal searchlights illuminated the sky, but the Avengers had already launched their torpedoes and begun their withdrawal. Bai observed the explosions through night binoculars. 5 confirmed hits against 2 cruisers and 1 destroyer. The mission demonstrated that the modified torpedoes were effective even in complex combat conditions. The success validated tactics that would become standard for American night operations, redefining what was possible in the Pacific theater of war. The night in Rabaul transformed into a spectacle of lights and destruction. The torpedo explosions illuminated the darkness, revealing the silhouette of the hit Japanese ships. Bui felt a wave of satisfaction. Years of hard work and frustration were finally bearing fruit. The ability to attack at night with such precision and coordination was a game-changer. The Japanese, accustomed to a certain predictability in night attacks, were caught by surprise. Their searchlights and anti-aircraft guns fired frantically, but the threat had already passed. Bai's tactic, combining new technology with bold execution, proved devastating. For the Japanese sailors, the darkness, which once offered some protection, now seemed to hide an even greater danger. With each explosion, the belief in the safety of their ports and the effectiveness of their defenses disintegrated, replaced by a new and terrifying reality. Admiral Soemu Toyoda, Commander-in-Chief of the Combined Fleet and Yamamoto's successor, convened an emergency conference to re-evaluate the threat of American aerial torpedoes. Field reports indicated that Japanese naval losses had tripled in 6 weeks. Toyoda faced a reality his predecessors had not anticipated. Japanese superiority in naval armaments was being neutralized by American innovations. Captain Kameto Kuroshima, Chief of Strategic Planning, presented a detailed analysis of recent attacks. The data revealed a consistent pattern. American torpedoes now operated with 78% reliability, compared to 23% 6 months earlier. Kuroshima recommended a complete review of defensive formations and the accelerated development of countermeasures. Toyoda authorized an emergency program to modify naval tactics, but recognized that the window of opportunity was closing. Japanese industrial capacity could not compete with the speed of American innovation. Toyoda understood that naval warfare had entered a new phase, where technological adaptability was more important than initial superiority. The conference room was filled with a somber atmosphere. The admirals' faces reflected the gravity of the situation. Toyoda, a man of great experience, felt the weight of responsibility. He knew that the Imperial Navy was losing the innovation race, and the consequences would be terrible. Kuroshima's presentation, with its relentless charts and statistics, painted a bleak picture. The reliability of the Mark 13 torpedo, once a source of ridicule, was now an existential threat. The idea that American inferiority had transformed into a decisive advantage was difficult to accept, but the numbers did not lie. Toyoda saw the bitter irony. The same confidence that had propelled Japan to great victories was now blinding it to reality. The decision to modify tactics was a necessary step, but he knew it was a palliative measure. The real battle was being fought in laboratories and factories, and there, Japan was losing. At the Mitsubishi facilities in Nagoya, engineers worked desperately to develop countermeasures against the improved American torpedoes. Chief Engineer Jiro Horikoshi, designer of the legendary Zero fighter, led the effort to create detection and interception systems. Horikoshi analyzed fragments of modified Mark 13 torpedoes, searching for exploitable vulnerabilities. His team identified that the stabilization devices created a distinct radar signature during the first seconds of fall. Horikoshi proposed the development of a short-range radar specifically calibrated to detect approaching torpedoes. The system would allow a 15 to 20-second warning, enough time for evasive maneuvers. However, the production of specialized radars would require resources that Japan could no longer dedicate to experimental projects. Horikoshi also investigated the possibility of physically intercepting torpedoes using modified anti-aircraft projectiles. Preliminary tests were promising, but the necessary precision was beyond existing Japanese capabilities. Frustrated, Horikoshi concluded that the best defense would be to completely avoid engagement with American air forces. a strategy that amounted to an admission of defeat, a devastating blow to Japanese pride. Horikoshi's genius, which had created one of the war's most iconic aircraft, was now focused on a defensive battle, a race against time he knew he was losing. The frustration of seeing his brilliant ideas limited by a lack of resources and strategic inertia was immense. He understood the science, the physics behind the new torpedoes, and knew that the answer was not just more armament, but a fundamental change in how the war was fought. The idea of avoiding aerial combat, of retreating in the face of enemy superiority, was bitter. It was a tacit recognition that the era of Japanese technological supremacy had come to an end. For Horikoshi, the war had transformed into a cat-and-mouse game, where the American cat was always one step ahead, and the Japanese mouse was running out of hiding places. With each passing day, the hope of a technological turnaround diminished, replaced by the harsh reality of disadvantage. Commander David "Dave" McCampbell prepared the largest torpedo operation of the war to date. The mission targeted the Japanese fleet concentrated in Leyte Gulf, including the super battleships Yamato and Musashi. McCampbell had meticulously studied the specifications of the Japanese ships, identifying specific vulnerable points. The Musashi, 863 feet long with 16-inch armor, seemed invulnerable to conventional attacks. However, McCampbell knew that well-placed torpedoes could cause critical structural damage. The tactic involved coordinated attacks from multiple altitudes. Some Avengers would launch from 2,400 feet for maximum precision, others from 1,200 feet to saturate defenses. McCampbell emphasized that each torpedo was precious. The production of modification devices still did not fully meet demand. The success of this mission would determine whether American aerial torpedoes could effectively threaten the world's largest warships. The tension before the mission was almost unbearable. McCampbell's pilots knew they were about to make history or become part of a tragedy. The Musashi and Yamato were legends, symbols of Japanese invincibility. Attacking them with torpedoes, a weapon that had been a source of shame, was an act of audacity. McCampbell, with his calm and determined leadership, instilled confidence in his men. He had planned every detail, every attack vector, every launch moment. Coordination would be key. The sky over Leyte would become a stage for the final demonstration of the transformed Mark 13's power. For the Americans, it was a chance to prove that innovation and adaptability could overcome brute force and tradition. For the Japanese, it would be a brutal awakening to a new reality, a blow that would shake the foundations of their naval supremacy. Captain Toshihira Inoguchi commanded the super battleship Musashi when the first modified torpedoes were launched against his formation. Inoguchi had navigated the Musashi through multiple engagements, relying on the ship's massive armor and advanced defensive systems. The super battleship displaced 72,800 tons and carried 9 main 18.1-inch guns, the largest naval armament ever installed. Inoguchi observed the approach of an exceptionally large American formation, more than 40 aircraft in multiple attack waves. The first wave launched torpedoes from a surprisingly high altitude, forcing Inoguchi to divide his anti-aircraft fire between threats at different levels. When the first torpedoes hit the water, Inoguchi realized they ran straighter and faster than any American torpedo he had encountered. His evasive maneuvers, effective against previous torpedoes, were insufficient against the improved precision. 5 torpedoes struck the Musashi in sequence, each causing progressively more severe damage. As the ship sank, Inoguchi transmitted his last observations. Enemy torpedo capability completely transformed. Capital ships are no longer safe from air attacks. The Musashi sank 3 hours later, taking with it the Japanese illusion of naval invulnerability. The fall of the Musashi was a seismic event, a tremor that resonated throughout the Imperial Navy. Inoguchi, in his final moments, witnessed the end of an era. The ship, which had been built as a symbol of unwavering power, was now bowing to the force of innovation. The explosions, the sound of metal twisting, the cries of men, all this composed a symphony of defeat. Inoguchi's message, transmitted amidst the chaos, was an epitaph for the old naval doctrine. The belief that armor and size could protect a warship against any aerial threat had been shattered. The Musashi was not just a ship, it was a philosophy, a declaration of power that had been refuted by a torpedo that, just a few years earlier, was considered a joke. The tragedy of Inoguchi and his ship was the tragedy of a nation that had refused to see the truth until it was too late. In command centers in Tokyo, military analysts processed devastating reports of increasing naval losses. Lieutenant General Torashiro Kawabe, head of military intelligence, coordinated an urgent investigation into enhanced American capabilities. Kawabe had consistently underestimated America's capacity for rapid innovation, assuming that Japanese technological advantages would remain stable. The data now contradicted all previous projections. In 3 months, American aerial torpedoes had sunk 2 super battleships, 5 heavy cruisers, and 12 destroyers. Kawabe ordered a complete review of all threat assessments, but recognized that it was too late for fundamental strategic changes. The Imperial Navy had lost the ability to replace capital ships, while the Americans continued to expand their fleet. Kawabe understood that the underestimation of the Mark 13 represented a catastrophic intelligence failure. Japanese confidence in technological superiority had created a fatal blind spot, allowing the Americans to develop a decisive advantage without timely detection. This failure exemplified broader problems in the Japanese strategic mindset: overconfidence and systematic underestimation of the enemy's adaptive capacity. Dr. Vannevar Bush, director of the Office of Scientific Research and Development, received enthusiastic reports about the success of the Mark 13 program. Bush had coordinated the collaboration between universities, government laboratories, and private industry that made the torpedo's rapid transformation possible. The project demonstrated the effectiveness of the American approach to military innovation: rapid problem identification, mobilization of diverse expertise, and accelerated implementation of solutions. Bush understood that the Mark 13's success set a precedent for future armament development. The ability to turn failures into successes through systematic engineering would become a distinctive feature of the American war machine. Bush authorized the program's expansion to include submarine and naval torpedoes, applying the same stabilization techniques to other platforms. The methodology developed for the Mark 13, rigorous scientific analysis, extensive testing, and continuous refinement, would be applied to subsequent projects, including the development of nuclear weapons. Bush recognized that the war had become a competition of innovation systems, where the speed of adaptation determined victory or defeat. Admiral Chester Nimitz, commander of the Pacific Forces, reviewed operational statistics that confirmed the fundamental transformation of naval warfare in the Pacific. In 6 months, the success rate of torpedo attacks had increased from 18% to 76%, completely altering the balance of naval power. Nimitz understood that the improved Mark 13 had become a decisive strategic weapon. The ability to effectively threaten Japanese ships of any size allowed for more aggressive and flexible tactics. Nimitz ordered a reorganization of attack formations to maximize the use of modified torpedoes. Torpedo squadrons received priority for more experienced pilots and more advanced aircraft. Logistics were reorganized to ensure a continuous supply of modification devices for all operational units. Nimitz also authorized an accelerated training program for torpedo pilots, recognizing that the improved weapon required correspondingly sophisticated tactics. The Mark 13's success validated the American strategy of technological warfare, using industrial and scientific superiority to overcome the enemy's initial advantages. Nimitz predicted that this approach would determine the outcome not only of naval warfare, but of the entire conflict in the Pacific. In the waters around Okinawa, the Mark 13's transformation reached its peak during the largest naval battle of the war. Commander Joseph "Joe" Clifton led a formation of 72 Avengers in a coordinated attack against the last major Japanese fleet. Clifton had participated in the first tests of the modifications 2 years earlier, witnessing the weapon's complete evolution. The Japanese formation included the super battleship Yamato, the last symbol of imperial naval power. Clifton knew that sinking the Yamato would definitively demonstrate the supremacy of aerial torpedoes over traditional naval artillery. The American tactic had evolved to lethal perfection, simultaneous attacks from multiple directions and altitudes, completely saturating enemy defenses. Clifton coordinated the launch of 144 torpedoes in a pattern covering an area of 2 square miles. The Japanese responded with desperate anti-aircraft fire, but the multiplicity of threats made effective defense impossible. Clifton observed 23 confirmed hits against the Yamato, each Mark 13 torpedo functioning exactly as designed. The largest battleship ever built sank in 2 hours, marking the definitive end of the naval artillery era. The Mark 13's transformation had completely redefined the nature of warfare at sea. Clifton's vision, as he watched the Yamato be swallowed by the waves, was the culmination of years of effort and sacrifice. The steel giant, once considered unsinkable, was now succumbing to ingenuity and adaptability. Each torpedo that hit the target was a silent testament to a nation's ability to learn, innovate, and overcome. For American sailors, it was a victory not only tactical, but also moral, proving that persistence and science could bring down even the most imposing symbols of enemy power. The smoke and fire rising from the Yamato were a grim beacon, announcing the end of an era and the dawn of another. Naval warfare would never be the same. The lesson was clear. Strategic rigidity and underestimation of the enemy were more dangerous than any weapon. Adaptability, the ability to turn failure into strength, was the true key to victory. In the Imperial Navy archives, final records documented the magnitude of Japanese underestimation. Lieutenant Commander Masatake Okumiya, a survivor of multiple torpedo attacks, compiled a post-war report on Japanese intelligence failures. Okumiya had witnessed the complete evolution, from the first ineffective attacks to the final devastation at Okinawa. His analysis revealed that the Imperial Navy had fundamentally failed to understand America's capacity for rapid innovation. The Japanese mindset, based on established technological superiority, could not anticipate that the Americans would transform weakness into strength through systematic engineering. Okumiya identified multiple points where timely intervention could have mitigated the threat: development of countermeasures, modification of defensive tactics, or early recognition of the American transformation. However, overconfidence and systematic underestimation of the enemy prevented adequate responses. Okumiya concluded that the war had demonstrated the superiority of innovation systems over static technological advantages. The ability to adapt, improve, and transform rapidly had proven more valuable than any individual weapon, a lesson that would redefine future approaches to military development and technological strategy. Okumiya's reflection, written in the shadows of defeat, was a lament and a warning. He had seen arrogance turn into vulnerability, confidence into despair. The story of the Mark 13 was not just about a torpedo. It was about a nation's failure to adapt, to recognize change. The lesson was universal. Innovation is not a luxury, but an existential necessity in times of conflict. The war in the Pacific, with its vast expanses of ocean and brutal confrontations, had become a laboratory for human adaptability. And in that laboratory, the nation that learned fastest, that turned its mistakes into lessons and its weaknesses into strengths, was the one that prevailed. The silence of Okumiya's archives echoed the bitter truth that the greatest weapon of all was not steel or gunpowder, but the human mind in its incessant search for solutions.